All right, so today we are going to start reference angles. It's the last topic that we have to get into in regards to getting ready for next week, Tuesday's test. If you haven't taken a peek back at the calendar board in the back, you have a formative today. You have a formative on Thursday, and you have a test next week, Tuesday. Along with all of that, don't forget that your extra credit unit circle projects will be due a week from tomorrow. Okay? All right. So, we need to talk about reference angles, and before we get to talking about reference angles, we have to first talk about what an angle is in standard position. Okay? So, an angle in standard position, this is bugging me. An angle in standard position has its vertex at the origin. So our vertex will be at the origin to start. The second condition for an angle being in standard position is that the initial side, which is the horizontal side of this particular angle, the initial side is along the positive x-axis. Actually, I shouldn't even say the positive x. Yeah, no, I will say the positive x-axis. Yeah, yep, that would be the standard position. The other side of an angle is called the terminal side. Initial is where you start. Terminal is where you end. Okay? Initial to start, terminal to end. Okay? So then the measure of an angle is the amount of rotation from the initial side to the terminal side. A positive angle would have counterclockwise rotation. A negative angle would have clockwise rotation. You know all of this so far. Okay? Because that's unit circle. Okay? Unit circle, the angle starts at the positive, on the positive x value or x-axis. Okay? Positive angles go counterclockwise. Negative angles go counterclockwise. We've been doing this for a week. We're just putting words to the actual definitions. Okay? Okay? So if it's in standard position, then our initial side is on the positive x-axis, and our vertex is at the origin, and our terminal side is somewhere else. Okay? And then that tells us what the angle is. Okay? Oops. That one. There we go. Coterminal angles. Okay? So a coterminal angle is an angle with different measures, or angles, I should say, with different measures but the same terminal side. Okay? Those are coterminal angles. So for instance, let's say I lock in an angle here of 30 degrees. Okay, we'll go in degrees today to make it easier, but we could also go in radians. We could say pi over 6. With me? Okay? So theta is 30 degrees. A coterminal angle would be negative 330 degrees. Would you agree with that? Because if I start here at 0, right, and I go backwards around, that's negative 330 degrees. What about 390? Oops, let me put it in a different color so that they are 390 degrees. If I start here, I go all the way around, that's 360, and I go 30 more, that's 390 degrees. Give me another one for 30 degrees, a coterminal angle for 30 degrees.
So if it was in radians, it'd be the same radians.
So if it was in radians,
right?
it would be pi over 6, right? So then the green one would be negative 11 pi over 6. The red one would be 13 pi over 6. Understand? Okay, because you got to add 2 pi. Okay, go ahead, what? Negative 690 degrees. Do we agree with negative 690 degrees is another one? So another rotation is 360 degrees. So you'd add, so I would go negative, what'd you say, 690?
Yeah.
I would go with that. Give me another one. 750 degrees. How we getting those coterminal angles? How do we find a coterminal angle? You had me, then you lost me. It literally sounded like you were going through a dead zone in your on your cell phone because I heard like every third word. No, I'm not going 330 degrees either way. I'm going a whole lap around. Yep. Okay, so I'm either going to add 2 pi if I'm in radians, or I'm going to add 360 degrees, or I'm going to subtract 2 pi or subtract 360 degrees. A whole lap, all the way around. Okay? All right? So knowing that now, find and draw a positive and negative angle that is coterminal with the given angles. Okay? So you do those 2 examples for me now. Negative 150 degrees is right here. So my list of positive coterminal angles with negative 150 degrees would be 210 degrees. Actually, we can draw this a little bit better. What else would we have? 210 plus 360, 570. 8, 9, 30. 12, 30, 12, 90. Yes? What's up? $150? Huh? Yeah, I suppose. I mean, as long as it's in quadrant 3, it really doesn't matter. Oops, I drew it in purple then. Is that better for you, Bestie? You're welcome. What's up?
Okay, I don't understand why you're just adding 360.
Because that's another lap around the circle. It gets me a coterminal angle. An angle in the same position with the same terminal side.
So you're at, when you got 210, you added 360. Because I just did 360 minus 150.
As long as you go negative 150. You know what I mean?
Yes. So for the coterminal values, some of these were negative, none of these will be negative?
Nope, because it said give me a positive and negative 1. So now we're going to go with the negative ones.
Will it say on the test how many?
Yep. Okay. So then let's go with, what's that, 410? 510? 410? Which one? 510? 1170, 1230. 1530, 1590. Oops, I put a double negative. Yes? Standard rule of thumb, if your angle is given to you in degrees, then we want the answer in degrees. If your angle is given to you in radians, we want the answer in radians. So on this next one, we want that in radians. So 2 pi over 3, that is up here. So the positive angles would be, so I'd be adding 6 pi over 3 every time. So it'd be 8 pi over 3, 14 pi over 3, 20 pi over 3.
I get why you'd add 6 pi, but why wouldn't it be like 3 pi? Because it's like all of 3. So don't you just have to add a whole rotation?
A whole rotation is 2 pi. 3 pi over 3 is only a half of a rotation. Yep. That's why it's 6 pi. Yep. Okay. The negatives then would be negative 4 pi over 3, negative 10 pi over 3, negative 16 pi over 3, and so on and so forth. Okay. Questions, comments, concerns, clarifications? All right, reference angles now. Okay.
Here I thought that it was over and it was easy and we were done.
So, what I would like you to do is I would like you to find me theta if the terminal side of theta goes through the point -3 comma -2. Okay? Find me theta if the terminal side goes through theta.
Does terminal have to be positive?
Nope. Doesn't matter.
This is going to take a while.
And what do you add?
It is not on the unit circle. Yeah, you do actually. Yeah, you actually do know how to do it. Because you passed geometry in order to get here.
Well, Theo, square geometry.
It's like we've been using right triangle trig.
So x is -2. We don't know how the height is.
Oh my gosh, I think I got it. That's 3, that's 2. You use that. Shoot.
Okay, so then that's a
Definitely, I'm on the right
Agree.
Yes.
Agree that theta is 33.6901 degrees.
Yes.
No, I got theta as that.
You don't need to add the 180 though, because it starts here. Whatever angle.
Yes? No?
That
Maybe?
angle starts on that line.
Yes?
Oh,
Show of
yes,
hands.
yes.
How many people agree that theta is 33.6901 degrees? Raise them high. Be proud of your wrong answer. Yeah. Be proud of your wrong answer. Why is it the wrong answer? Initial side is always on the positive x-axis.
So it is plus 180.
So what?
It is plus
It
180.
is plus 180.
I felt like
Why?
this when I
Because
said
where
that.
is theta?
In the third quadrant.
Theta is right here. This whole angle right here is theta. Yeah. Okay. What did we actually find as 33.6901 degrees? We found something called the reference angle. Okay? So we actually found something called the reference angle, theta prime. Okay? Theta prime is the acute angle. Acute, remember, is between 0 and 90 degrees, formed by the terminal side of theta and the horizontal axes. Okay? So, theta prime, you're going to need to know this. Big time stuff right here. I'm going to put it in with, let's go with 2. I want to go with, what is it? It's the creative pen.
Yes.
I want to go with 2 stars and 2 smiley faces. Theta prime is always off the horizontal. Okay? Theta prime is always off the horizontal. 2 stars and 2 smiley faces. You need to know that because there's going to come a point in time, probably within the next 24 hours, for sure within the next 3 months, that you're going to say, oh, my reference angle is off the vertical, off the y-axis. No. Okay. Reference angles are always off of the horizontal axes. So, let's talk quadrant number 1. If my angle is in quadrant number 1, then theta is equal to the reference angle. Oops, here, tap the brakes. Go back a little bit. I'm going to put that in a little nicer way. That's theta. So then I want to say theta equals theta prime. Okay? Quadrant number 1 is the easy quadrant. Quadrant number 2. theta is now here. So theta prime, or my reference angle, is, well, I shouldn't say that. My angle is equal to 180 degrees minus theta prime, or pi minus theta prime. Nope, because
Why?
that would come off the vertical then.
Oh, yeah.
Theta prime is here.
Oh. Oh, okay.
Quadrant 3. There's theta. There's theta prime. This is like that case that we were just in. So then theta is going to be 180 degrees plus theta prime, or pi plus theta prime. Quadrant 4. It's a little long. There's theta. There's theta prime. That's 360 minus theta prime, or 2 pi minus your reference angle. %100% on this? Yeah? You haven't even written anything down yet. Got all 4 quadrants? I didn't think so. I'm glad that you're able to carry on a conversation and disrupt the entire room. But that's good. You keep going. Okay? What's up? The red right here? This one? That's my reference angle.
So it's based off.
It comes off the horizontal.
I get all of them, but quadrant 2.
But quadrant 2?
Yeah.
Okay?
When you, cause like you said, the theta prime is that angle.
Because theta prime comes off the reference, or off the horizontal. So that's theta prime.
Okay.
Yep.
That's the only one that's really fun.
Okay? Let's do it. Let's put them into work. Let's do some here. Okay? So let's find theta prime. Okay? So it helps to draw yourself a diagram, a little picture, a quick little sketch. Okay? So 125 degrees is right up in here. Reference angles come off of the horizontal, so I need to find this angle in here. So that's going to be, my reference angle is going to be 180 degrees minus 125 degrees. So I get a reference angle here of 55 degrees. Oh, yeah. The size of the red angle, yes. The angle, reference angles come off the horizontal. Okay? You find me the reference angles for number 2 and number 3. So that's 220, which means that my reference angle here is 40 degrees. Agree with me on that one? 310 degrees is there, which gives me a reference angle of 50 degrees. Agree? I don't know why you got 40, because it's 360 degrees all the way around the circle. So if you go 360 minus 310, that leaves you with 50. Okay? Now, one last thing that I'd like to do here is I would like to compare sine, cosine, and tangent to theta and theta prime. So at your tables, what I'd like you to do is I'd like one of you to type in, if you've got 3 people, one of you to type in sine of 125 degrees, one of you to type in sine of 55 degrees, show them to the third person at your table, and they're going to see if they're exactly the same or not. Okay? So we're comparing sine right now. Sine of 125 and 55. Sine of 220 and 40. Sine of 310 and 50. First one, same, different, same. Second one, opposite. Third one, opposite. Okay, now compare cosine. Cosine of the reference angle and the actual angle. First one, opposite. Second one, opposite. Third one, same. Okay, lastly, tangent. Now do tangent of them.
What's this angle? 310.
First one, opposites. Second one, same. Third one, Opposites. Okay? Does that make sense? Greta, why does that make sense to you? I'll go back up to the where the actual pictures are.
It makes sense because of the quadrants that they fall in.
That's the only reason. Because of the quadrants that they fall in. Okay? Where is sine the same? In what?
The first and second.
First and second quadrants, right? Okay. Where is 55 degrees? First quadrant. So that means if I have a reference, or if my theta is in the second quadrant, they should be the same. Yep. Where is cosine the same? One and 4. So cosine should be the same over here if my theta is in quadrant number 4. With my reference, because my reference angle is always going to be where? No, where is my reference angle always going to be? In quadrant number 1, because it's an acute angle. So it's always going to be in quadrant number 1. Tangent's the same where? 1 and 3. So that's this one. That one was the same. Okay? Alright? What I would like you to do now is, now I would like you to clear everything off.